In this video, we're going to begin our discussion of bonding. Now, bonding is a little bit of you got to be a little bit careful with that word bonding, because a lot of times when we talk about attractions between one atom or another, or one molecule or another, that can be considered a chemical bond. Sometimes we just consider it an attraction. So the first thing we're going to do is we're going to talk about the difference between those two. So the remainder of Unit 2, we're going to talk about several different types of chemical. And I don't even like to use the word bonds here because, again, they're all just attractions. Some are stronger than others. So instead of bonds there, let's use the word attractions because, again, bonds isn't everything. Okay, so hopefully these little 1 and 2 here will kind of help you organize in your brain the difference between a bond and just an attraction between one molecule and another. And again, we've mentioned this a little bit, and this number 2 here, this is going to be the new stuff. This is from regular chemistry, but this all here is going to be brand new in AP. So when we talk about the intra, and I know we've discussed this already in previous videos, that when we talk about the intramolecular attractions, that's within the molecule, those are the actual bonds. That's where, yes, you call them a bond. It is, again, within a compound, within a molecule. Okay, and so, for example, with water, you've got HOH. Okay, that right there is a bond. That is the attraction between a hydrogen atom and an oxygen atom within that molecule. Okay, when a chemical change happens, when a chemical reaction happens, it's those bonds that are changing. They're breaking, they're forming new bonds. Okay, that is when we talk about a chemical change, those bonds are the ones that are actually changing. Okay, when we talk about bonding, there are 4 main types of bonds that you need to know. There are ionic bonds. There are what we call covalent bonds. Often we call them molecular bonds, or a lot of times we just call them molecules. Okay, and again, we're going to talk about each one of those 4. And then there is metallic bonding, and then there's also what's called network covalent bonding. So it's kind of a different form of covalent bonding that's called network covalent bonding. You've probably maybe remember roughly the first 3, but that last one is one that we don't cover in general chemistry. Okay, now that's one category, again, are the bonds. Okay, the second category, again, are not bonds. Even though sometimes they use the word bond, okay, it's not a bond. Well, why do they use the word bond? I don't make the rules, okay? So, when one molecule, here's the molecule, water, when one water molecule is attracted to another water molecule, okay, right here between them, I'm going to make a dash line. Again, that is the intermolecular attraction, not a bond. Okay, so it's the attraction that exists between one molecule and another, not the attraction here and here or here and here. Those are the actual bonds, the intramolecular attractions in the molecule itself. Okay, when a physical change happens, when something goes from a solid to a liquid to a gas, etc., okay, you're breaking or you're creating new intermolecular attractions. Okay, you're not changing the intramolecular attractions, you're changing the intermolecular attractions. Now, the types of intermolecular forces that we need to be familiar with are what are called hydrogen bonding, not a bond. They call it hydrogen bonding, not a bond. It is an intermolecular attraction. What are called dipole-dipole forces and what are called London dispersion forces, okay? And again, don't worry about any of these 4 yet or these 3 here. Focus on what's an intramolecular attraction or bond and what's an intermolecular attraction. Again, notice I didn't use the word bond when I said intermolecular. Okay, I used the word bond only when I said intramolecular. So, you're asked to draw 2 water molecules, okay? again, this is kind of a review from regular chemistry, and this is something we're going to cover here in just a little bit. But I don't really care if you remember exactly how to do it, because I just drew it up above. So here's one water molecule. Okay, and notice that it's always the oxygen. I always put the oxygen closest to the to that other hydrogen in the other molecule. We're going to learn why here. Okay, and I'm going to put that dash line again. Okay, so there's my two water molecules, and here I'm showing the intramolecular bonding. So that again is the bond, and then over here is the intermolecular attraction. Now, well, which one is it? Is it hydrogen bonding, dipole, London dispersion? Don't worry about it. We'll get there. Okay, we haven't learned anything about intermolecular forces of attraction. We just know that when two things are stuck together, like in ice, when a whole bunch of water molecules are rigidly held together, what's holding those water molecules in the solid form are the intermolecular forces. Okay? When you start to heat that ice up and you start to weaken those intermolecular forces, the water molecules are still stuck together, but they can kind of move around a little bit. You've weakened those intermolecular forces. And you heat the water up enough, those water molecules are able to break apart from each other, and you're able to completely break that intermolecular attraction there. One water molecule goes off into the air, so does the other water molecule, and you've completely broken that intermolecular attraction. Okay, so example 2 says a student claims that when energy is transferred to a piece of ice, we just talked about that, the OH bonds found between the atoms, not between the molecules, between the atoms, within the molecule are broken. Do you agree or disagree with this claim? Justify your answer. You better disagree with that claim. Okay? And again, you don't get anything for saying disagree. You say disagree, and then your explanation gets you a point for having the correct answer. So here's what's nice, guys. Again, if you're grading the AP test and the person writes agree, you don't have to read anything else that they write. So make sure that you answer the question correctly. Okay? Is the energy that's transferred used to break the bonds, the OH bonds? No, it's not. So I'm going to say disagree, and I'm going to say that energy, and again, lots of different ways you can say this, is used to weaken the intermolecular, and yes, you have to use that word, intermolecular attractions. And then you can say not the bonds. Okay? And that again, you're showing the greater look. I know that when a physical change happens, it's the intermolecular attractions. Gosh, I'm sorry, my handwriting's terrible. Hopefully you can listen to me and not try to figure out what I'm trying to write down. So energy is used to weaken the intermolecular attractions, not the bonds. Okay, now our next part is we're actually going to start talking about the 4 different types of bonding: ionic, covalent, metallic, and network covalent. But again, that's going to make the video much, much longer. So let's stop right here for today.